Hello, we are now going to learn a lesson entitled Assumptions in Hypothesis Testing for a single mean. We will be talking about the null and the alternative hypothesis. This lesson will have three parts. The first part will deal with test of significance. Significance, people use the word significance. So, we have to distinguish between practical significance and statistical significance. Let us go to the lesson. The first module, assumptions in hypothesis testing for a single mean and the null and alternate hypothesis. Part 1, test of significance, practical significance or statistical significance. The learning objectives are: describe how a probability value is used to cast doubt on the null hypothesis. Define statistical significant, distinguish between statistical significance and practical significance. We need to check whether an experimental result might have occurred by chance or not. We shall discuss in more detail about the logic of hypothesis testing. We shall consider two examples for our discussion. A person is asked to guess by tasting a product, tea or soft drink, whether the product is prepared according to method A or B. It is assumed that the numbers of preparations by A and B are equal. The second experiment, called B, a dog was claimed to have been trained to choose even or odd number from a given set. Assume that this set has equal number of odd and even numbers. In each of these experiments, the outcome may be or may not be affected by a random phenomenon. If there is a mere guess, then the probability for a guess is 0.5. If the contestant has some talent, then this probability would be different from 0.5. By assuming a simple guess by the contestant, we compute the probability for a particular number of correct guesses. Suppose that the person correctly guessed in 13 out of 16 attempts. We can use binomial probability for this occurrence. Here the parameter n equal to 16. What about p? Please remember, binomial probability is defined for two parameters n and p. Here n is 16, p is unknown. If the person is simply guessing, then p equal to 0.5. With this value, the probability for 13, 14, 15 and 16 correct guesses is computed as 0.0106, less than 0.2. If he has some talent, then the p value is more than 0.5, which we could not know. Here the computation is not possible. What does the calculated probability mean? The probability of 0.0106 is the probability of a certain outcome, 13 or more out of 16, assuming a certain state of the world, that is, the person was only guessing. It is not the probability that his ability is true. He may have the capability of correctly guessing, and hence he might have got this number of correct guesses. Look at the second example. Suppose that the dog correctly guessed 9 out of 16 attempts. Therefore, the probability for 9 or more correct guesses in 16 trials is computed as 0.40. Would you conclude that there is a 0.4 probability that the dog can tell the difference? Certainly not. We note that the probability value is actually the probability of an outcome, that is 9 out of 16 or better, due to chance guessing and not the probability of a particular state of the correct guesses, that dog was correctly guessing. This is the state of world. I would to say this. This calculated probability value is the probability of an outcome given the hypothesis, is not the probability of the hypothesis given the outcome. Our rule to make a decision is, if the probability of the outcome given the hypothesis is very small, we have evidence that the hypothesis of mere guess is false, that is, he is not guessing. In case the probability of this occurrence is high, we conclude that it is a mere guess, low probability, high probability. Please note this difference. In the case of dog experiment, the probability for correct guesses is a large value. That is, the number of successes is a chance occurrence. When a hypothesis is rejected, we say the outcome is statistically significant. Statistical significance means that there is a small probability for this occurrence. People use the word practical significance when the result seems to be significant according to their personal opinion. There is no statistical basis for this word. The results that appear to be practically significant have been shown to be not statistically significant. An example from chemistry. Henry Cavendish in 1785, while investigating atmospheric nitrogen, had suspected that the weight of atmospheric nitrogen was heavier than that of nitrogen extracted from rocks. His work was forgotten until Lord Rayleigh, more than a century later, found that nitrogen prepared by removing oxygen from air is about 0.5% more dense than nitrogen derived from chemical sources such as ammonia. This difference in weight is very small and is regarded as significantly low, practical significance of low value. But later this value is shown to be statistically significant by the use of t-test for two sample means. Further research showed that there existed a gas which was denser. It was later named as argon gas, and for this discovery Lord Rayleigh received the Nobel Prize in Physics 1904. Please note that a simple t-test led to a Nobel Prize. So, this underlines the importance of studying statistics. I think this will motivate you to learn statistics. Let us summarize what we have learned in this part. We have learned the probabilistic basis for rejection or acceptance of a hypothesis. We defined the concept of statistically significant. We distinguished between statistical significance and practical significance. We will continue our lesson in the next video. Thank you.